My name is Anna Steffi in group 19.
I am Zach Barnett, also in group 19.
I'm Alana Jadwalis, also group 19.
I'm Dolin Jia in group 19.
And this is our discussion of recitation 4.
Yes.
And so the first problem, we are posed with the question of a binary star system. And with part 1, we worked a little through it, but I'm still questioning on like how best to explain like the system and part of the question.
I got the same answer, and I feel like we could explain that with addressing the net force. I think the net force over time is still 0 since there are no external force by the surrounding being applied to the system.
See, explaining it through the net force being 0.
Yeah.
That probably means that force is constant, or just no, that there's just no force at all.
Yeah.
This is meant to run the greater. So yeah, we worked through all these problems together. Did everybody get the same answer for this question, part 1?
Yes.
Yeah.
Which was 0, which is the system at rest. And then for part 2, this is just my outline of what I would do with my numbers, but not why I think my estimates that I made are actually accurate. So I was wondering, like, anybody's thoughts on that?
Well, yeah, I think it kind of goes back to what Gio was saying, is that the only force here is what we already talked about. And there's no external forces that we have to take into account. So I don't think we have to worry about anything like that. So just talking about what we have here and what's presented to us, I think would lead to more accurate results.
Yeah.
I think it also has something to say that like the change in velocity is like insanely small compared to the overall velocity as well. So I think like the approximations are really, really good, especially if the approximation is like as minute as it is.
Oh, the velocity is smaller than the speed of light.
Oh, true.
Yeah.
All right, and part 3, the last part for this question. Estimate the changes. You can use your previous results. Yeah, this was done really quickly. Did everybody get the same answer here as well?
Yeah.
Yeah. Yeah, because then the total momentum, like the momentum from A and momentum from B should cancel out. So then you would just like make the momentum of A and the negative of the momentum of star B.
Mm-hmm. Yeah, due to the like conservation of momentum or whatever.
Yeah.
Mhm. Then this is not a question. And then for problem 2, it was just one. In outer space, a small rock strikes a stationary large rock. State all objects. So did everybody kind of derive a formula like this? I put like 1 instead of like, I think I put 1 for small rock and 2 for big rock, just to explain, like, and yeah, because momentum needs to be conserved, which was like the top problems whole thing as well. We know that like any change in momentum that we've been given between initial and final velocity, the difference of that needs to be unloaded into the larger rock. And so I just took the difference of that onto 2 final, because the initial of this is just at rest, which is 0, 0, 0. And momentum is just mass times velocity.
Yeah, I got the same answer.
Mm.
Yeah.
It should be.
Yeah, I literally just found the momentum of I believe it was a small one, and then just changed the signs.
Mm.
Talking about kind of the assumptions that we may have made. I think
Oh,
one
yeah.
of the biggest assumptions is that this interaction is completely elastic, and that it will, all the energy that's put into it comes out of it. Like none of the rocks are crushing or anything. That's not something we have to worry about. We're worried they hit each other and they rebound with the same amount of energy they came in with.
Yeah,
Mm.
like no energy loss.
Exactly.
I think, yeah. Gravity, etc. That's obvious. We're in space. Something else?
What would you put for the system and surroundings? Like,
Probably like large and small rock would be the system. Wait, are they both the system?
I would say so.
oh,
Wait.
I thought it was just a big rock. It was just a system.
yeah, I put for the
Oh.
large rock as the system.
Because that's what we're measuring, right? And then the system is what interacts with what we're measuring.
Oh, yes.
Yeah, I think if we are studying like only the momentum of the large rock, it should be probably just the large rock being the system.
Oh,
I agree. That makes a lot of sense.
yeah.
All right. So everybody happy with what they've seen?
Yeah.
All right. Then we are done. And I'm gonna-